Hi OSLO users. In this video I'm actually going to show how to build a CCL, and to do that I'm actually going to generate a useful routine that allows us to document and write a formula sheet for our lens by putting a few commands together. So I've got the double Gauss lens open here, and let's say I know nothing about CCL and I'm starting from scratch. You can certainly always go here and type in CCL in the help, or look at the written documentation or PDF documentation that we also have. And if I come here and look at CCL, there's a whole bunch of different things we have here. CCL programming is a nice place to look. Also under contents, there's this entire programming sort of thread. So CCL is essentially compiled command language, and what it is it allows us to we can certainly do some mathematics, and we can tie together different C-like commands, or C commands essentially, that as well as call SCP program files and routines, and we can also call other CCL programs, and it's just a very powerful built-in language. But the thing we have to do with this is we have to write it, save it, and then we have to be sure to compile it. And there is one thing that is very important when you're going to compile. When you compile, it's going to want to compile this entire directory. And so the .ccl extension is used when you know something is going to compile. If you have a few different commands that aren't compiling at the moment, but you need to do your work and have the directory compile, you can save them as .ccx. You don't necessarily have to move them out of the directory entirely. So what happens when we compile is all the .ccl in the directory that we're compiling are all compiled at once. Once they're compiled, they run faster than uncompiled code like SCP commands. So I almost exclusively use CCL because it's quite powerful, and it's pretty easy to get around issues when you've got bugs or you're in the middle of developing something and it's not compiling. So a lot of documentation there. All right, let's do it. Let's build this SCP program, or sorry, this CCL program. I just did the SCP and SCP example, so that's why I'm have this bad habit of saying that at the moment. Okay, so here we have a new lens file open. Let's go ahead, and you can type in void, which is C syntax, but in CCL you can also use command. And I'm going to call this lens report CCL. And in C syntax you have to include the brackets, the parentheses here for arguments. And I use an open curly bracket, close curly bracket. So this is actually a command, even though at the moment it doesn't do anything. In terms of the commands I'm going to use, and I went through this in another video, but I'll go through it quickly here too. We have 4 commands. We have PXS, which is going to give us the paraxial setup of the lens and tell us how to launch the light in. RTG, which for spherical surfaces gives us all of the pertinent, what the glasses are, what the thicknesses are, what the curvatures are, gives us all the information we need in order to document the lens. And then I usually include these last 2. I usually include wave, which tells me what wavelengths are defined in the lens, and that's used because the last one I include is RIN, which is the refractive indices. The refractive indices are dependent upon what wavelengths that I have defined. So I want to be sure to put both the wavelengths and the refractive indices. Why am I doing that? Well, if you've ever actually picked up an old design or had somebody send you something where you don't have a particular glass, or a glass has become obsolete or is no longer in the code, and this can happen, then it's really good to have those refractive indices documented so that you can look to find an equivalent more easily. So that's the routine that I'm going to use. Now I need to save it. And when I go to save as here, I have to save it with .ccx, and I have to save it in the right location. So let's go ahead and go about doing that. The location that I'm going to want, since I am writing this code, there are certainly a bunch of CCL in the public directory, but I'm going to want to do save this in my private directory. So private CCL, and here I'm just going to call it lens report CCL. Now, the text editor here that I've opened, so this is Notepad++, it doesn't necessarily have CCL as an option for you. There are a whole bunch of other options here. So this can be a little bit annoying if you don't have it as completely defined here. So you can go to all types here and we can just put in .ccl, and I believe that will work. We'll check that in just a moment. And if I go here, oh, I look up here, it's a .ccl, which is what I expect. So be really careful about that. Now I have it saved in that directory, but if I were to try to run this, and I'm going to go ahead and do that, let's see what would happen. Hint, hint, it's not going to do anything. So I paste that, I run it, and it says, I don't know what you're talking about. And the reason for that is I have not actually compiled the code. So to compile it, this little button here will compile all the CCL. There is a place to do it up here as well, compile CCL, or you can just type in CCL. In this case, I will just hit this little star. Since I have not made any syntax errors here, you can see that the CCL has compiled no problem whatsoever. So now if I go and I hit just Control V there, and if I go to run this, now it runs and I have my handy routine built and I can do whatever I want with it. So that is the very, very basics of building a CCL program, and it's a useful routine that we've built with it.